What's going on, guys? Welcome back to another video, and in today's video we'll be going over sets in Python. Sets are the last data structure in our inbuilt data structure series. We went over lists, we went over dictionaries, tuples, and now we're on to sets. Sets, they're another way to store data, but the three things that we need to know about sets are: one, they are unordered, they are also unique, so they do not allow duplicates, and the elements inside of sets are immutable. Sets themselves are not immutable, but each element in a set is immutable. So those are the three things you gotta know, and that's what separates sets from lists, tuples, and dictionaries. So let's get into defining sets, changing them, and all of that fun stuff. So to create a set, we're gonna use curly braces. If you watched my dictionaries video, you know that we also define dictionaries with curly braces. So we cannot do set. Let's just do this underscore set. So we cannot just do this, because if we actually print the type of this, it will say it's a dictionary, because a dictionary also uses curly braces. So it says class dictionary. So in order to define an empty set, we can just do set like this. So this is an empty set. To add elements to sets, or to define a set, we can just do the curly braces, and then we can place elements like this. I accidentally just dropped my mic. I'm sorry about that. So this is how we place elements. We define a set, and we can print this underscore set. Alright, so you can see it prints the set down here. Alright, so that's just how we define a set. We can also define a set by doing from a list. So we can do set and then this. So if we pass a list to this set method, then it will also create the same thing. All right. So those are the ways that you can define a set and define an empty set. We can also add elements to sets. So say we have this set here, and we can do this underscore set dot add, and let's just do 5, and then we can print. So you see here, I actually added 5. I said earlier that sets do not allow duplicates. So even though I added this 5 here, it's not. You see it. There's only one 5 when I print this out. That's because sets only allow one element, and you'll see that again later. I'm gonna do that again later to show you that it will only allow one element of each. So by doing this add method, we added 6 here, and just adds it to the end of the set. These sets are, remember, they're also unordered, so I cannot just do this set, this underscore set 0, for example. This is invalid. You'll get an error if you try to use this. Alright, we can also do, so we have the add, we can also do this underscore set dot update, and we can pass a list to this, so, or any iterable, and let's just do 7, 8, and now it has 1 through 8. Okay, so that's how we add elements to sets. We can also remove elements from sets. So there are actually 4 ways that I can think of that we can remove elements from sets. The first is remove. So this underscore set dot remove. Let's just remove 8 and print it. So we removed 8. We can also do this underscore set dot discard, and let's do 7. Now you may be wondering, what's the difference between remove and discard? Well, say we didn't have 8. Actually, let's do, to show you, if I do this set dot remove 10, we will get an error. So if you don't have the element in the set, remove will give you an error. If I do this for discard, it will still run perfectly, but it just won't remove. There is no 10, so it's just not removing 10. So remove will give you an error, discard will not. Okay? But they both remove the element that you specify if it's in the set. We can also do this underscore set dot pop. Now, this underscore set dot pop, because sets are not ordered, not indexed, it will just pop a random value. So it's not popping the last item from the set because Python doesn't keep track of that. So it will just pop anything. In this case, it popped 1. So 1 is no longer in the set. And then the last method is this underscore set dot clear. That was a disaster. Wow, I am just not typing well today. So this underscore set dot clear, of course, this will clear the set. And I expect that we'll get an empty set. We do. So this just clears the set. Alright, so that's how we add and remove items from sets. Now we can get into arithmetic with sets. So sets are actually unique in the case that you can do these arithmetic combinations with sets, meaning that you can add sets together, you can intersect sets, you can get the difference between sets. It's actually pretty interesting, and I'm going to show you guys what I mean by this. So let's say we have 2 sets. Let's just do set 1 and set 2 for convenience. So let's set 1 equal to 1, 2, 3, 4, 5. And set 2 is 1, is 4, 5, 6, 7, 8. So we have 2 sets, each have 5 elements, and they have 2 of the same elements, 4 and 5. So first thing we'll do is we'll do union. So what union does is it really just adds the sets together. And let me actually draw this. Let's showcase my amazing drawing skills. Beautiful circle there. So say I have 2 circles. What union does is you can just imagine it would take everything that they share is included. So all these elements are included. So this is set A, this is set B, and this is what's in between them. This is set 1 and set 2, and it'll just have all the elements. So in order to do union, what we can do is we use, I don't even know what's this called. It's like this symbol here. I actually don't know what that symbol is called. If anybody knows, please let me know. It's like a vertical dash, I want to say, but yeah, this is the symbol that we use for union. We can also do set 1 dot union and then set 2. Both of these do the same thing, but you'll see what this would do is it'll print out literally 1 through 8, and it does. So in this case, the middle here, yes, it adds them together. These both share 4 and 5, so they both have 4 and 5. But remember, sets do not allow duplicates. So the 4 and 5 that they share, it will just combine into 1, 4, and 5 because there's no duplicates. So we have union. We also have intersection. So intersection is all the elements that both the sets share. So back to my wonderful drawing skills here. If I have these two circles here, this is set 1, this is set 2. This is what the difference, the intersection will display. So in this case, you might have guessed it, it will be 4 and 5. And to do intersection, we do the ampersand, so set 1 and set 2. And then we can also do set 1 dot intersect. Intersection set 2. And again, these would do the same thing. So 4 and 5, these are the elements that are in both but not exclusive to one. Alright? We also have difference. So difference is the elements in one but not the elements in the other. Okay, so if we think about difference, we're just subtracting this from this. So anything that's in here but not in set 2, so anything that's in set 1 but not in set 2 will be included if we did set 1 minus set 2. So in this case it will be 1, 2, 3. So if I print set 1 minus set 2, this should print 1, 2, and 3. I'm actually going to put an empty print so you can see. So yep, 1, 2, 3 down here. Actually do the same thing for this. So we have union, we have intersection, and then at the bottom here we have difference. So if we did set 2 minus set 1, it would just be all the elements in set 2 but not set 1. So that's 6, 7, and 8. Alright, and again, it's actually funny. You see how it changes the order here because sets are not ordered. So it does 8, 6, 7. So that's actually pretty funny. Then the last thing is symmetric difference. So what I mean by symmetric difference, so if we think about the symmetric difference, we're thinking about the elements that are this is kind of hard to explain, elements that are in set 1, in set 2, but not in both. So if let's go back to my diagram. So it's just all the elements in set 1, in set 2, but not in both, okay? So in this case, it's all the elements except 4 and 5. And this is actually a pretty weird one. The symbol for symmetric difference is this up arrow. So print set 1 dot up arrow set 2, and it does print 1, 2, 3, 6, 7, 8 as expected. So that's symmetric difference. And yeah, that is all we will go over today. There's also frozen sets which are interesting. We won't go over that in this video, but if you did enjoy this video, make sure to like, comment, and subscribe. And I hope you learned something, and I hope to see you in the next one. Take it easy.